Good morning everybody, we have brought a video on the magnetic effects of electric current. Enjoy yourselves.
Thank you.
The area around a magnet where a magnetic force is experienced is called the magnetic field. It is a quantity that has both direction and magnitude. The magnetic field is a field produced by the magnet or electric charge in motion. The magnetic field is the region around a magnetic material or a moving electric charge within which the force of magnetism acts. Magnetic fields are represented using magnetic field lines. It is a visual tool used to visualize the direction and the strength of the magnetic field.
Patterns formed by magnetic field lines differ according to the change in shape of conductor. So let's first talk about the patterns of magnetic field lines due to a straight current carrying conductor. First, we set up a straight conductor we talked about. Insert a thick copper wire in the center of a white cardboard piece. Now connect the copper wire to a battery along with the rheostat and plug key. Close the circuit by making sure the cardboard piece is fixed firmly. Sprinkle some iron filings on the cardboard and tap gently. We now observe that the iron filings are arranged in concentric circles around the wire. These concentric circles show the magnetic field lines formed due to the current flowing through the copper wire. So over here we conclude that the patterns of magnetic field lines formed due to a straight current carrying conductor are concentric circles, which become larger and larger as the distance from the conductor increases. The fact over here is, instead of using iron filings, the same pattern can be also obtained by using magnetic needle. Keep a magnetic needle near the current carrying conductor. We observe that the needle gets deflected. Let's increase the current in the circuit using the rheostat. Now we observe that the deflection of the magnetic needle increases, which indicates the magnetic field gets stronger. So from this, we conclude that the increase of current, the magnetic field increases. Now keep the magnetic needle a bit farther from the conductor. We can see the deflection of the needle decreases, which indicates the magnetic field gets weaker. So we conclude, with the increase in distance, the magnetic field decreases. Hence, from the two above observations, we get magnetic field is directly proportional to the current, whereas inversely proportional to the distance. The question is, how do we find the direction of the magnetic field? Here is where the Maxwell's right-handed thumb rule comes in handy. Maxwell's right-handed thumb rule states that if we hold a right thumb in the direction of the flow of current, then the direction in which our fingers curl to grasp the conductor shows the direction of the magnetic field.
Factors on which magnetic field produced at center of current carrying circular wave depends are.
Let's talk about magnetic field due to
Now
current
here
in
you
a
can see
solenoid.
the pattern of
What
magnetic
is a
field
solenoid
lines
now?
around
A coil of many
current
circular
solenoid,
stones of
and
insulated
it is
copper
similar
wire
to a
wrapped
magnetic
closely
field
in
around
shape
the
of
bar line.
cylinder
In
is
fact,
called a solenoid.
The fact thing is the field lines inside the solenoid are parallel straight lines, and they indicates the magnetic field is the same at all points inside the solenoid, and the field is uniform inside the solenoid.
Electromagnetic induction. This concept was discovered by Michael Faraday. How galvanometer is useful in this process? A galvanometer tells us if the current is flowing or not, and it also tells the direction of the current. Where a magnetic field changes with time through a coil and a current flows in that coil, this phenomena is called electromagnetic induction. To change the direction of the current, it can be done by moving the magnet through the coil, or changing the polarity of the magnet, or moving the coil itself. Fleming's right-hand rule. Stretch the thumb, forefinger, and the middle finger of the right hand such that they are perpendicular to each other if the forefinger indicates the direction of the magnetic field and the thumb shows the direction of the motion of conductor, then the middle finger will show the direction of the induced current. Thank you.
Thank you.